Hello everyone. Today we are going to learn about Git and GitHub in detail. I'll try my best to cover each and every topic. So please stay till end. This will be one short video in which you will get in-depth knowledge of Git and GitHub. So this is my self-prepared PPT. So we'll talk about what is Git, what is GitHub, how to take care of your source code and everything. So this is the basic things which we are going to see that what is Git, what is open source development, the features of Git, how to set up Git, what is GitHub. Then we'll see some scenarios, basic stories, and everything example, and we'll go one by one. So, what is version control? Everyone must have heard about that. Git is a version control system, and some might be confused between what actually is Git and what actually is GitHub. Some people might get confused that Git and GitHub are same, but actually they are not same. So we'll see in each and everything. Please stay till end. So first of all, the very important thing is Git is never equal to GitHub. These two are different things. Git you use locally in your system, and GitHub itself name suggests that it is hosted on cloud, and it's a kind of repository where all your projects will be stored and their version control and everything we'll see. So what is Git? Git is free and open source distributed version control system. So you might get confused what is open source, what is distributed. So everything I'll tell you, open source is something for which you need not to pay any amount. You can use it, it is available for all and free of cost. That is open source. And it is designed to handle everything from small to very large project with speed and efficiency. And who created this? This is created by Linux Torvalds in 2005. It was basically first made for Linux kernel. So Git use क्यों करते हैं? We want to track our changes of source code. Like if you are developing any application, let's say you are coding or you are developing any application, and with you there are different group of people, bunch of people who are working with you. So you all are working on different features of a particular project. So it is not like that you will complete your task, then another person will pick the task from where you left and will work on the functionality. No, everyone develops at the same time. And what they used to do to keep track of what they are doing, to manage like what commits they are doing, uh, they use this tool, we can say Git, to track their changes in source code. And in Git, we do commits. Commits basically means if you have done some development and you are happy with the code changes, that these changes will do the required task, like functionality is included by this line of code I have done. So you can commit it on Git. It will store your snapshot of the project. It allows multiple developers to work simultaneously without overwriting each other's work, and it works offline, and later when you are happy you synchronize it with remote server like GitHub. So it Git is open source distributed version control system. Then this is a command line interface also. You can use Git commands, like some of you must have noticed when you are working in your college projects and all. In VS Code, what we generally use to run the commands are git init, git add dot, git commit, and all those things. That is the command line tool which you are using. There is something we call terminal or command line which you can use, or you can use git bash, that is also command line utility, or you can use tortoise git, that is a kind of GUI interface which in which you need not to type commands manually. You just, if you want to commit, just click on commit option. If you want to like add something and all, for all these things you need not to write commands. You will directly use a GUI interface, that is tortoise git. Okay, so what basically Git do, it allows you to manage and track changes to your file over time. And whenever you create a repository, you always see .git directory. You can try it creating in your local system. It keeps track of file history. tracks changes and who made all those changes. And I told you about commit. Commit is the version of each version of a file is a commit. Git is, you can say, it's a all rounder in a team. If you has mess up something, like for example, you thought that your changes are good, but what happens is your senior developer says that this is something we cannot push further, we cannot take it further because it is impacting other things of the existing application. So you will get confused what to do. How will I go back to my previous state and all? All those things can be handled very easily using Git. We can roll back our changes using Git very easily. And if Git wouldn't be there, if you would not be having track of your file changes, then it would become very difficult for you to manage all the things under development in a large organization. You must have seen, I told you that Git is a open source software, free distributed. So what is open source in that? Open source, you can just remember this. How much it's open source? It's open source itself means it's free of cost. Source code is made available for public. Anyone can use it, view it, modify it, and distribute it. And what is the benefit of this? It is transparency. The biggest advantage is transparency. There is nothing that is hidden from the customer, and there is nothing that is hidden from the user and the producer, you can say. And you can customize as you want. So these are some features of Git that it provides us good speed, security. It's open source, it is scalable, and we can create our clean history. We can maintain, we can collaborate using Git, and these are different features of Git. Now, if we will deep dive into some more features, so what is distributed? Distributed means every developer has the full history of their repo, not just the latest version. Even if GitHub is down, you still have full repo locally. If you must have noticed that this kind of symbol, if you have noticed in IntelliJ or VS Code, on left bottom there is this kind of symbol that is Git symbol only, which shows you all the full history locally also, and it's a version control system which keeps track of all the changes with unique commit id. That's why these commit ids are used. If you want to see what particular changes you have made, or in future you want to roll back the particular commit, you can easily do because there is a unique commit id given to each commit, and each commit we call a snapshot. And Git is also used to create multiple branches. We can create different branches and we can use these different branches for different purposes. For example, there can be one trunk branch in which developers are making active development, and there can be some branch like defect branch, you can say, if there are something uh, a bug or some defect have been raised by the tester or someone. So all those fixes you can do in the another branch, say defect branch, and later you can merge those branches. And you can use like how data integrity is maintained. So it uses SHA-1 hashes to ensure that integrity is maintained and there is no corruption. For example, if a file is modified, its SHA changes immediately because every time you are making any commit, it is giving it's a unique ID. So it will not be same for any if modification. If you will make any modification, the commit ID will get changed. There is a concept of staging area, that means stage selected changes before committing. That if you don't want to, like this example, you can say git add index.html. It means only that file is included in that commit. You don't want to add all your commits at all in a git. You want only a particular file to be there on remote repository, and in local you have so many changes, but you don't want to push all those changes. Then you use this concept of staging area. And Git also allows multiple developers, they can push and pull the changes via remote. This is the git push command you must have used. And you can revert, reset, and use reflog to recover your commits. Okay. And give git store changes as deltas, not full copies. So it is very fast. There is no lag in this. And if you are setting up the Git very first time, so you have to globally set your username and user email. And which, if you are using Git Bash, you can use these two commands. You can give your username, whatever GitHub username you have, and whatever email you are using, and this should be registered with GitHub. This is the first time setup process. Now, what is GitHub? So don't get confused. Basically, you can think of it as a remote repository, and it is a web-based platform. Its name itself suggests that it is a web-based and source code management system we can call, and it is used to host Git repositories and to share it with other and enabling collaboration. And it was launched in 2008, whereas Git was launched in 2005. A remote repository in which you can host your local repository. For example, you have a particular project in your local system, you are working actively on that particular system. Now you have completed your development or you are in the process of development. So you can host them on GitHub. So from that GitHub, all other people can get access to that particular project. But if you are working on Git here locally, then you can't share it with other teammates and all. So we place that whole project in remote repository. And these are the different things we'll see in future, that what is fork branch, what is master branch, what is, basically you can think this is your local system in which you are working in Git. So this is your working directly. Say you are coding in Java, and you have your IntelliJ setup. Then you have created a very basic program, say example hello world program. Then what you will do, first of all, if you are using command line, you will initialize Git using git init command. Then you use git add dot means it will make all your changes to get added to some repo. But in between, if you are adding, there will be one stage which is called stage. And after that, if you will commit with a particular message, it will go to some repository. And then you can later on merge it with different repository. For example, you have done development in trunk, and later you want to merge it with feature branch, so you can do that. And then there is remote server, from where, before, what as a developer we are using in industry is, we first pull the changes that are there on remote repo, because on remote repo many developers are working. You don't know whether the file you have worked upon is being changed after you pulled the latest code, or maybe some other developer has done some commit. There are some changes in that particular file in which you have made some changes now, and which you are going to push now. So to ensure that there might not be merge conflicts later on and there won't be any complications, what we prefer, we'll first pull the changes that are there on remote repository to our local system. From remote to local system, we'll pull those changes. Then only once that is done successfully, Git exits cleanly, then only we'll push it to remote repo. So this will ensure that there is no any merge conflicts. See, before Git, what how before 2005, how things were working. So what we used to do, like we used to save a file, and there might be chances that it might get overwritten, and there are some, there we have to maintain it locally via file.txt. Then we started saving new files, like if you are wanted that history, what are the changes, then you started naming like file underscore one, file underscore. But this is very complicated, very space consuming, and there is a lot of duplication. And if you want to backtrack, there is no partial backtracking. So these methods were not efficient, and as the technology is enhancing day by day, these methods can't fit in today's generation. So now it's a story time. So imagine you are writing a story. You start with a sentence, and the version one of the sentence is, the cat sat on the mat. You can see in this image. Then you decide to make it more exciting. Then you thought that the fluffy cat sat on the beautiful mat. Then your friend suggested you some changes that the sleepy, fluffy cat sat on the beautiful woven mat, and this will be this. But you realize, like, your version 2 was better. This cat you think is the perfect one for the task you are doing. So, how will you go back to that? Did you save a separate file for this, or how will you manage it? Because this will get after you are after you have created the version 3, it's difficult to go back to version 2. And this is just an example of a cat, and there are lot of thousands of files. So how will you manage to go back to a particular version which you feels like is the most suitable one? So this all gets messy if we don't have Git. But this whole problem has been solved by Git. See, a simple analogy, building a book together. There is another example. If you and your three friends are writing a book together, okay, if you don't have any version control system, if you don't use Git, so what you will be using? Everyone must be thinking of either Notepad or Microsoft Word. So you thought of writing first version, and you wrote this in book underscore v1 dot docs, okay, and you mail it to everyone. So if people will be making changes, they'll email back you with some editing in that first one, and they'll send you this version 2 with this name. Okay. And then another person will see and make some changes and send you with his changes. Then again another person will make some changes, and in the end you had one file. But you know how you have to manually copy paste every time you are change making the changes, every track of file you need to keep, and there is so much duplicacy of those files, and there will be very messy kind of situation and inconsistencies will be there. So it's very difficult for us to work as a developer on these all things, like maintaining the word file or notepad or something. So these all problems are solved by version control system, that is Git. What Git does is it will put a master copy on GitHub. It will create one book copy on GitHub. Then everyone will clone on their own computer using git clone command and using that URL. Everyone will get that book on their local system. So one friend writes a chapter on character backstories, for example, and another write on grammar, another worked on main story, and different things they did. Then when all these things are done, grammar fixes are done. So what you will do? You will push those changes to remote repository while merging it with the main story. You will merge it with the main story and you'll put it to the remote repository. And you can see each other changes and each other comments and suggest improvement because before they are finalized. And if you like in the ending you wrote last night and you want to revert to the previous version, for example, in the end, for example, we thought of that cat example, we after creating the version 3 of cat we thought of going back to version 2. These kind of thing can easily be done with version control system because it will manage the entire process automatically and it will take the snapshot of every step. You can see every commit because every commit has its own unique ID with it. Now, for example, if you are managing a project, it would be very difficult if you don't have version control system. So, if you don't have version control system, say you have three files, you edited those files, some files are added and some are removed. So, in version 2, you are left with one of A is modified and B is deleted and C as it is. Okay. Then again, A is modified, a new file is added, and C is also modified. So how will you manage all these things? So it is very difficult to realize here that B file has been deleted because you won't be aware that which file has been deleted in version 3. You need to go back, and it would be very messy and very difficult. So you'll go to the previous versions and can access when required. So what is version control? Version control, and we have learned about distributed version control. So, version control system are tools that automatically track changes to your files over time. I think now I need not to explain, you must Remember this with the example. Version control is also known as revision control or source control. It allows you to revert back files to previous state, compare changes over time, see who last modified something that might be causing a problem, work on new features without breaking the main project, and collaborate seamlessly with others. And what is distributed version control? So in traditional version control, you can clearly see an example. There used to be one server and one repository, and everyone was accessing that server only. But in distributed, we have different clients, and different clients have different repo, and they are collaborating with each other. They need not to connect to a central server. They can work without internet connection, and every developer is a client, and the every server you can think of as a repository. And developers can work independently and merge their work later on. See, for example, in computer one, you have working copy. Okay. Then you made some commit and you push those changes to the repository by taking some updates first, pulling the code, then you commit it on repository. Then you will first what you will do from the main repository. This you can consider a particular developer. This is developer one. Okay. So this is remote repository. So what this developer will do first, it will pull the changes. Then only when the pull is done, this is the preference. You can also push then pull. Then you need to resolve merge conflicts. You can uh, get some very difficult, complicated situations if you want pull the changes first, because there might be chances the file you have worked upon, there might be chances that someone else has worked upon that file and that might be changed there. So it's better to first pull the code, then push your changes. So think of it as computer one as developer one. This is developer two and developer three. They all have their working copy. They have made their changes. So from main repo, what they'll do, they will first pull the change, then they'll push. There might be chances that this and this are together pushing, pulling, and there might be different situations which can happen. But remember, if you are working, if you are pushing something on remote repository, first pull the latest code, then only push, so that minimum merge conflicts are there and you can easily resolve them. And this repository is GitHub. Distributed version control system, you got to know now. This workstation as developer 1, 2, 3. Now, what are the benefits of version control system? You got to know. You can keep track of the history. You can roll back your changes. You can easily merge and you can easily collaborate with the team. There is chances that your data in future get lost, and you if you want to recover a particular version, and if you want the backup of a particular version, you can use it. And there are different kind of things. And you might be thinking, what is attribution? Attribution means you giving credit to the original author or source, because every time a commit is made, the person name or the employee ID or the username what they have in industry will be visible, that this particular person has made this commit. So you can keep track what features and functionalities and is being added in a particular application by a particular person or a particular developer. Now, what is repository? You might be thinking that we have seen this is repository, repository, repository. So what is repository? This is nothing but a collection of all the files, and the history of those files is known as repository. It contains different folders, images, files, spreadsheet, Excel, dataset, and anything you want will be in repository. Folder like structure containing all necessary files. You can say it consists of all your commits. Whatever commits you are making, that will go in a repository. It is usually used to organize a single project, a place where all your hard work is stored, you can say. For example, you have a calculator project, and I told you, whenever you will run a command git init, git folder will get created. And these are different folders which get created in a Git repository, and these are the part of working directory, bin, source, com, and all this thing. This is another example. For example, eh, this person has edited this. This is local repo. This is local repo. First they'll pull, then they'll push the changes in the remote repo. simultaneously they are working. So first of all, as soon as you will initialize the Git, this is the basic workflow. So .git folder will get created. Okay. Then you will add your local changes. Then it will move to the staging area. Once you add your local changes, then you will commit those changes to the remote repository or GitHub, we can say. For that, you will use git commit command and your changes will be moved to repository or GitHub. Now, you added two files, so both the files first went to staging areas, then you made a commit to the remote repository. But make sure before pushing anything in the remote repository, try to pull the latest code first, then only do these steps. So Git uses a three-tier architecture. We know that from working area, it will go to staging area. If you will run the git add command, then from staging area, it will go to repository using git commit. And first you will check out it. First process will be you will check out the repository in your local system, then you will work in your local system and make the required changes, then you will add it in staging area, and from staging area you will commit your changes. Key concept, first of all, to create a git project in existing directory, you use git init. Make git start to watch for changes in the directory. For that you need to run git init command. Then to add git add, if you want to add only one file, say index.html, then you will use this command git add index.html. This add command will put that file into the staging area. Then you want to take the snapshot and you will create a commit. Once you will do a commit, particular commit id, unique id will get generated and your files will be passed on to remote repository, and you can give a commit with a message. For example, git commit minus m double quotes my first commit. My first commit will be the commit message here, and you can use git status to see what is the current status of your working directory. Is it in staging area or where it is? You can use it to check it using git status. And if you, for example, have uh, like ran the command git add and your status is in staging area, so to unstage a file but you want to retain your changes in the working tree, you use this reset command, git reset head and file name, whatever the file name you have. And if you want to discard current changes in working tree and make it look like last commit only, then you will use this git checkout hyphen hyphen file name. But be careful, you will lose your changes and you cannot get them back because you are discarding them. You are not keeping any track whether you have, because your commit was not completed at this time, na? So again, you can see this example. This is remote repository, this is local repository, and this is staging area. This is working directory. First, you will from remote, your it will come into local, and from local, everything I have already told you. So core concept is git init, git clone. If you want git clone, now you must be thinking from remote repo we are getting the code first. I am saying you to pull the code first. So how will you pull that in your local system? So for example, if you don't have git project and you are setting it up for the first time from GitHub to your local, then you will use this clone command, git clone and the URL of your GitHub project. And once you already have a project and then you made some active development, and before pulling the code, you will use git push command to take the changes from remote repo to your local repo. Three areas we have already seen: working, staging, and repository. And files can be in modified stage, or stacked stage, or committed stage. Git add will add it to staging area. Git commit will save a snapshot and will generate a unique commit ID. Git status and git log are used to check the state and history. See, for example, if you'll see git status, the output, if you type this command git status, the output will be something like that you are on master branch. There can be different branches and changes to be committed. These changes and you can commit and all. This kind of output you will be getting. If you are using git log, then using git log you'll see what is the commit id. This will be always unique, and what is the message or whatever commit you are doing, and who is the author and what is the date time. This all you can see using git log command. If you want to see how staging area look like, then try to run git add command. It will take the snapshot of the file that will be commit, and you can change the file after adding it. So you can check status after that using git status command. Then if you want to remove a file, then you can use git rm and file name. It will remove your file from the working directory and in the next commit. And if you want to remove it from the next commit but keep the file in the working directory, it should remain in working directory, then you'll cache it using hyphen hyphen cache between git rm and the file name. Now if you want to see the differences of file, so you can use this command git diff hyphen hyphen cached or git diff. So for example, git diff head. So there you can see that minus minus means these are deleted and plus plus means these things are added. For example, blah blah blah. This is version 1. Okay. So after that, this is blah blah blah. This is line 2 of version 1. And this is line 2 of version 1. This is line 3 and 4. This all things are like, you can see that this might be the differences. These are two different colors shown. Now, git ignore. It is very important that, for example, if you want something or some file you have stored password or some information that you don't want to put on remote repository, so that all files and the node modules and all that you will prefer to keep in git ignore, it won't get pushed into the remote repo. Specific files that you don't want Git to track under version control, and Git won't track these files. It is commonly used for compiled files, binary, and large assets file. Be careful if you are adding something to Git ignore after it is already been tracked. Potential issues may arise. So, either in starting only give something in Git ignore, or if you have already tracked it, so avoid putting that file in Git ignore. So how you can commit, we have already seen using add, it will go to staging area, then commit, then it will go to repository. Then what is branch? Branch concept in Git is like you can create a branch to work on new features or fix issues without disrupting the main code. If like you are working in in an industry, so there are developers, there are testers, and there are different QAs and all. So there is something like there will be one branch on which developers will be working. There will be one branch on which that QA will be testing, and in the end they these branches are getting merged and then they are being pushed with combined with you can say the main branch you have. So these different branches for different purposes and to work on different features we use. If your changes in one branch are good, you can merge them into the main code. If not, you can make improvements without affecting the main code base. This is the benefit of branch. For example, you can see branches will be visible here. You can click on view all branch. In GitHub, you'll see all the branches of a particular project. In Git, branches are just like pointers to these commits, you can say. Visualize a project development as a linked list of commits. We have already seen, like in DSA, a child points to a parents, or there is, you can say, a connection from one node to another. That kind of thing is there in Git branches. All commits in Git live on same branch, but there can be many different branches, and they can be combined to the main master branch later on. For example, this is the easiest thing I think you can understand. This is the history of release version. This is feature development. This is fixing bugs. And once all these are happy, they can get combined later on. If they are happy, they can combine into one main. Now, branching commands. It's very important. If you want to list all the branches in your project's particular project, then you can use git branch command. It will show you the list of all the available branches. But if you want to create a new branch, then you will use command git branch and you'll give a branch name. And if there is one branch that is already existing and you want to switch to that branch, like if you are in trunk branch and you want to go into the feature branch, so you'll write git checkout feature. And if you want to create and immediately switch, then you will use git checkout hyphen b and you can give a branch name. And if you want to delete a branch, then you will write git branch hyphen d branch name. And what is merge? I told you, an operation that applies the changes of a branch onto a master branch. So it will merge a particular branch with the another branch. For it is not necessary that you will merge all the branches in a master branch. There might be chances that your project requirements or anything, there will be different use cases for merging and there will be different use cases for different branches. And clone, I already told you, if a remote repo already exists, you can fetch a copy from your local machine and start working on it using the clone command, git clone, and you'll give that URL. It will download that particular repository or particular project from the remote repository to your local system. Branching and merging example. So very carefully see this. This is commit one. It is done in master branch. Okay. Then commit two. Then a new feature branch is created from this commit 2, and there is one commit 3 also going on. Okay, so in new feature branch there is active development being taking place, a functionality is being getting added. Then later on the functionalities are added and you want to merge it with master branch, so you can merge it easily like this visualization, I think, will help you to get a better understanding of merging. Now, say for example, I think that was enough, but you can go through this. For example, you made some changes till here, then till here. After that, a requirement came that you need to work on some different features. So you created a branch out of it, you worked on that development, and later on, when your development is done, you merged it. And the head will point here and changes from new branch merge into master. Now see. This is also another example that you created different branches out of it, and with time you merge them in master. There also one example, the different branches are getting merged and developments are going on. Git checkout master means it will um, checkout means switch your directory to the master branch, and git will update head to the point to the master branch. If you are currently like you are working on trunk, then you want to check out master, so you'll run the command git checkout master. So on trunk there was your head pointer, so git will update that head pointer to master branch now. Okay, git merge iss 53, git merge will merge this commit later with main branch. Okay, then now merge creates a new commit with two parents. Now it will be having two parents, like because two branches were there, so two parents it had. Before merge, master and new have diverged. These all I don't think you need to look into. These are just some logs and explanation. So snapshot. Here comes the important thing. The way Git keep tracks of your code history. Essentially, like the commit you are making. So what you expect, like in future, someone says you that who did this, who made this functionality working. So for that, you will have to, you have like say 10 developers. So you won't be remembering 1 month or 2 months later that who had made these changes. So you'll check that commit ID that is generated because of the snapshot only. Essentially records what your files look like at a given point of time. That is a snapshot. Snapshot name suggests that a particular point of time, how the things are there. You decide when to take snapshot and of what files you want to take snapshot, and it has the ability to go back and visit any snapshot. Think of it as if you are taking a photograph, you take a wide angle picture of the entire construction site. You don't just photograph the new window, you photograph the whole house, including the unchanged walls, roof, kitchen, drawing room, and everything. That is something the snapshot. And that wide angle picture is called snapshot. It's a complete record of what every single file in your project looked like at the moment you took the picture. Or you can say you made a commit. Snapshot of the changes made to the files in the repository at a specific point of time is known as commit. Commit stores information about what was changed, who made that change, and when change is made. These three things are very important. Keep it in mind. But basically, commit stores, it will store what was changed, who made the change, and when the change is made. And what is the initial commit? The initial commit is the very first snapshot or save point you create in new Git repository. It is the foundation upon which all future history is built. Initial name suggests that it is the first commit. You can only have one initial commit per repository. Okay. For example, you change your directory to this, then you init your uh, Git initialization is done using Git init. Then you ran this command. Readme.md file is for information. Then you added this is to staging area. Then you did this commit. This will be your first commit, and only one time it can happen for a particular repository. Okay. Initial commit is the only commit in a repository that doesn't have a parent commit. All other commits will have their parent commit, because this is called the root commit or the initial commit, from where the history will get derived. Creating the initial commit also officially creates the first branch. We can say usually we say it either main branch, master branch, or origin branch. Before the first commit, the branch doesn't truly exist. And there are three areas we have already read. Working tree is the consisting of all the files that you are currently working on. Index is basically the staging area where new commits are prepared. When you run this git add command, this is usually done before the commit. So it is the area where commits are prepared. It's an interface between a repository and a working tree. And repository, I already told you, where all your permanently changes will go, or you can say .git directory, and which stores all your files, folders, and everything. For example, this is the remote repository, this is index area, or this is working tree. You made some amendments here, then you will send it to staging area, then you'll commit those changes to a remote repository. So there can be changes made on the working tree will not be committed directly to the repository. They need to be staged on the index first. And there can be untracked files, unmodified files, modified files, and staged files. Okay. So this all is not much important, so you can skip it. Push, I already told you, it is used to upload all your local commits and changes into a remote repository. If you are like uploading your development to the GitHub or the cloud, so all your teammates or collaborates can access it, then you use this git push command. And the process of adding your local changes to remote repository is known as pushing the changes. So name itself suggests what is push, and this git push origin main. Origin is the default name of the remote repository, and main is the name of the branch you want to push on the remote. This can be feature branch, trunk branch, or anything. And this I already explained you. Your push to the remote repository will be rejected if your local repo is out of date, possibly because there are some updates that are on remote repo added by others that you don't have locally yet. That is what I said, that conflicts can occur. So to prevent this conflicts, what you will do, you will pull the changes first from the remote repo, then only you are allowed to push. So there is one machine, there is server, the commit is not on the remote repository. The commit is not on the remote repository. Okay. Then you can see how the push is working. Now how merge, and it's in a fast forward manner. You need not to go into this fast forward manner. It is not that much required, but it if can't do a fast forward merge, it will always fail. Then fetch plus merge is required and is allowed to push the changes. Once remote changes merge locally, again a fast forward is possible and the push will work. Okay, so you can see these example. So these are just some examples that what why conflicts can occur and how merge done, and all these are just examples for those merges. So remote branches. I told you about branches, and this is something we call remote branches. It's very similar. Remote branches represent the branches that are present on remote repository, that is GitHub. It will contain pointer to the state of a branch on a remote repository. It's your local Git's way of remembering what remote repository looked like the last time that you are connected to it. And they'll also allow you to see what you have done locally compared to what is there on remote. So there are reference points on for git push and git pull command. Git push, what it will do, it will update the remote to match your local branch, and git pull will update your local to match the remote branch. So these two things keep in mind. Don't sometimes people use push and pull interchangeably, but that is not so because they are for different purpose. Then remote tracking branch which is configured to track a remote branch is known as remote tracking branch. It will allow commands like fetch and push to know where to send and get the changes. It's helpful also to remember where a local branch points to. When cloning a remote repository, you will check out the remote master, and origin is the default name for that you cloned from. So origin slash master will be the remote branch, and master is used to configure to track it. So master is remote tracking branch. So don't get confused. What is origin? What is master? Origin is the default name of the remote repository you are cloning, and master is something that is tracking that is configured to track that remote branch, that is master. You can see this example creates when check out this, then it's tracking its local state, it's pointing to server and all those things. Then pull, the command that is used to synchronize the changes made by others in your code. If you want the code from remote repo to match, if you want your local repo to match what is there in remote repository, then you'll use this pull command. It's like merging two code spaces into one, or you can say the downloading commits that don't exist on your machine, and you are downloading it from the remote repository, that is known as pulling. And it's a shortcut command to fetch and then merge. Otherwise, if you will not use git pull, you will have to fetch it from a remote repo, then later on you need to merge those changes from remote branch into a remote tracking branch. This is pull command visualization. Sorry. This is how add, commit, checkout, merge, pull, push, fetch, clone. I already told you this is just a summary, that this is your local workspace, this is your remote repository. First of all, you will clone that repository. Once you are done with your cloning, you will do the active development. You can check out the branch. For example, you want you checked out feature, you cloned feature branch, but you want to make development in trunk branch. So you'll check out the trunk branch and you'll make your changes in your local workspace. Then you will add those files to staging area. But before that, you will first pull the changes from remote repo. Pull basically means fetching and merging. Then you'll add it to staging area. Then you'll commit it to remote repository, and basically you will push it to remote repository. So these two things, I can tell you in more detail that repository store is different and remote repository is different. Whenever you'll add a file, it gets prepared for a commit. Then you will make that commit. That commit will be there in repository store. And then if you run that push command, then only it will move to remote repository. In repository store, it is getting ready to be pushed on remote repository. And fork is something you can say creating the duplicacy or copy of a repository into your own GitHub account. You can then do any changes or experiment in that code that won't be reflected in your original code. It is very helpful if you want to try out something new in the industry. If you think that your code is better than original code, then you can create a pull request PR from the to that original code, and that PR needs to be approved by any of your reviewer or the teammate you are working with. Then you can merge it. That person will review those changes, approve the PR, and then you can work on. And what is a pull request? Pull request is like asking your team to look at the changes you have made in your project, in your separate version of project, and consider adding those changes to main project if they are good and ready. If they feel good about the work, they can merge your code with theirs. If they don't, they can discard and close your pull request. A simple Git workflow you can see first of all will initialize using Git init, then add that file to the text editor or directory use and then made the changes using git add dot will add it to staging area, then we'll commit minus m important message here or any message. This is another example again. Then how a commit message should be like, is it like we can give anything, but you should give it some meaningful, tell what it does in present tense. For example, you made some changes like in properties file, changes in properties file, you can give that message. It would be single line summary followed by blank spaces and followed by complete description. And it is the convention to keep it less than equal to 72 characters, or you can use any ticket or bug number. For example, if your industry is using Jira platform, then a Jira ID is there. So you can use that ID and that will help to track it later on that what commit, what does this Jira ID has done. Good and bad example. Type of X is something people will get confused. But if you'll write add missing section or something in CSS section, it will be easier for the other developers to understand. And these are some of the examples. And a good commit message explain why you made the changes. The code itself show what you changed. This is very like good line you can say. How to see what you changed? You can use git log command. And what is stashing? Stashing is a kind of temporarily saving your uncommit changes, both stacked and unstacked. So you can work on something else with a clean working directory and later reapply those changes. For example, once it happened with me, like if doing something like developing something in a particular branch, but I had some changes in my local which I don't want to push on Git, but at the same time I got another task on that same branch. So I thought of working in a clean working directly. So what I did, I stashed those changes, temporarily create a stash of that, and made my working directly clean, and then work on the latest task that came to me and pushed it on Git and committed it on Git. Then later on I'll apply that stash on my local repository. That will what it will do, it will give my all the changes I had that time, before that latest task, to my local repository, and I can continue working on that. Think of it as a temporary shelf. You can put your current messy work aside. Working tree must be clean when switching branch. Stash changes that you don't want to commit at time of git stash. puts a stash on a stack, later apply this all things I already told you. And if you want to remove the stash, use git stash pop command, as it works on stack, so you must be knowing about pop command. How to use stashing? Stashing, it takes all modified tracked both stage and stacks using git stash. Then you add a message to identify multiple stashes. Your working directory and staging areas are now completely clean, matching the last commit. You can now switch branches and pull new changes. So if you want to list all the stashes, if you want to see, then you'll run the command git stash list. And the latest stash is called stash at the rate in curly braces 0. The one before it is stash a1, and then this latest one is 0, before that will be 1, and before that 2, 3, and so on. And if you want to reapply your changes, you get your changes back and remove the stash from the stack, then you'll use pop command. Now how to use it, to get your changes back and keep the stash on the stack. So you want pop, you'll apply it. Okay, if you want to remove it from stack, then only you'll pop. You can also apply a specific stash by its naming, like not that latest one, but the one before the latest one, then you can use this. If you want to discard, then you will use this command drop stash at the rate one. If you want to discard all, then use git stash clear command. Head pointer points to specific commits in a repo. As new commits are made, then the pointer will get changed, and the head pointer will point to the latest change or the latest commit you have done. It's a special pointer to the current branch, you can say. Moves around as you switch branches. It will also move. It is always points to the tip of the currently checked out branch in the repo. It points to the parent of the next commit you are going to make, and it is reference of the most recent commit. For example, this is parent of this is parent of this, and this is parent of this, and this is the last commit, yeah, the latest commit you has done. That's why head is pointing to this. Which files were changed and where do they sit in tree tier? You can check it using git status. It allows you to see where files are in tree scheme, is in working area, staging area, or in repository where they are. What changed in working directory? You can check using git diff command. It will compare the changes to the file between repo and the working directory. Git diff stage compares staging index to repo, and git diff file name can be used as well. Then deleting files from repo, you can use git rm and file name. You can give, it will move deleted file change to staging area. It is not enough to delete the file in your working directly. You must commit that change after deleting it. So moving or renaming, you can do with git mv file name 1.txt to what file name you want to keep. This all we have learned. What if I want to undo changes made to working directory? Then what you can do is you can check out and grab that repo first. Then you will point check out this from current branch. Checkout means it will undo the changes you have done. What if I want to undo changes adding to staging area? It was in working directory, so we use checkout command. But if it is in staging area, then we will use reset command. Okay. What if you want to undo a committed to a repo, then you will have to amend your commit because you have already pushed it on remote repository. Now you want to amend your the latest commit. Okay, anything in the staging area will be amended to the last commit. And what files are there in repo, you can use using get it list of it using git ls hyphen tree and tree hyphen ishs. Tree hyphen ish is a way to reference to a repo full of head and everything. Tree is directory here. in which branch I am, you can check it using git branch. How do I create new branch? I already told, using git branch and new branch name. And at this point, both heads of the branch are pointing to the same commit. The one you will be creating the new branch, the head will be that only. How do I switch to using new branch using git checkout and the branch name? Then if you want to compare two branches using git diff command, and if you want to merge, then you can use git merge and the branch which you want to merge. Then fast forward merge occurs when head of a master branch is seen when looking back. There the fast forward merge will be done, and here new merge will be created, merge commit ID, or you can say. Recursive merge occurs by looking back and combining ancestors to resolve merge if there are conflicts. Now, what if there are two changes to same line in two different commits? For example, here it is apple and in this branch it's banana. There will be merge conflicts. So sometime two branches will edit the same piece of code in different way. Then you need to resolve it manually, and then you have to add those in conflicting files, and explicitly you have to resolve these and then commit it. Now resolving, it will annotate the conflicting files like this. Like in head branch it was apple, in feature branch it was banana. Whichever you want to keep, you can keep. And if you want to abort that merge, you can abort using git merge hyphen abort, or otherwise you have to fix it manually, or you can use any merge tool. Then graphing merge history is kind of, you can use this command git log hyphen hyphen graph hyphen one line hyphen whole hyphen hyphen decorate. So, tip to reduce merge pain is, before pushing any changes to the remote repository, first pull the latest changes, and always try to keep the commit small and try to be focused and try to merge often. It's not like you will be developing 10 days, then only you will push the code and will merge. No, regularly get the habit to merge often and to commit regularly the changes you are doing now, and bring changes occurring to master into your branch frequently. That is tracking. Rebasing is a kind of like advanced topic instead of merge, which creates a new commit originating from both branches. A rebase takes the content of one branch after the split and moves them into the end of the other branch. This command git rebase base branch takes your currently checked out branch and replace the differences on top of base branch only. So it will change the history of all the commits. Use locally only and for branches which you will never share. So rebase is, you can think of this example. This rebase is done on, if rebase is done on bx, committing will have c4 as only ancestor of c3. Okay, merging bx into by, these things will happen in both the cases. Now fast forward merge will occur. When to use rebase, it's very advanced topic, you won't be using it frequently. You have a local branch, you have some changes committed to it, then you can use it. You can use it instead of merging into remote branches, and there is, I don't think you will need this. So cloning, I already told you, git clone then url. This cloning from a remote repository allows teams to work together, and these all things you are able to understand now. How do I link my local repo to a remote repo? So that for that you will use this command git remote add, and you will give some name or URL then. This is just to establish a connection. No files are copied, nothing is getting moved. Yes, you can have more than one remote link to your local directory. Which remotes I am linked to, that you will check using git remote command. To see actual URL that these short names point to, you can use hyphen v flag, that is verbose mode, that is giving much detail, more detail. If you are pushing to remote repo, use git push command. If you are fetching from a git repo, you will use git fetch. Then later you have to run the merge command, or otherwise avoid it and go for pull command instead of fetch plus merge. Commit, it allows you to add to staging area. This all we have run. This git log we have learned. This renaming and deleting branches we have learned. Then tagging. Git has the ability to tag specific points in history as being important, such as releases version. Then we can use git tag command. And there are two type of tags. One is lightweight and one is annotated. A pointer to a specific command. Basically, a SHA stored in a file you can use, that is a lightweight. Annotated will be a full object stored in Git database. SHA, tagger name, email, date, message, and can be signed and verified with GNU Privacy Guard GPG. How do I see tags? You will run git show and the tag name. This is a kind of lightweight tag. You can see there is very less information, but here in annotated tag you will see tagger, date, and everything. Now what is SHA? SHA is something unique ID number for everything Git saves. It's a 40 character string of letters and number, hexadecimal number, which looks like something this. Think of it as digital fingerprint or a super accurate barcode. It is generated by a cryptographic algorithm, secure hash algorithm 1. How to use SHA hashes? You don't need to type whole 40 characters. You need to type enough characters to be unique in your repository. Usually 6, 7 are enough. You use the SHA hash to refer to specific comments for your various commands, and you can use these commands. You can see, check it later and recap. We all have done this. We have read about this. We have done all this. Git flow we have seen, and these are all the like references I have used for creating this PPT. So that's all for today, and I don't think any topic is left in this Git. So thanks all. Bye bye. If you like this video, you can like, share, and subscribe to my channel, and keep liking it and keep learning.